I am Dr. L. Vanitha, Professor in ECE Department, S.A. Engineering College. Welcome to the GATE discussion. We are going to say electronics and communications. There are 8 sections in this. First one is engineering mathematics, network signals and systems, electronic devices, analog circuits, digital circuits, control systems, communications and electromagnetics. In these 8 sections, we are going to see the topic about analog circuits. Let us see the syllabus in analog circuits. So, in analog circuits there are 3 sections. So, first one is diode circuits, and next one is BJT and MOSFET amplifiers, and third one is op-amp circuits. These are the 3 sections, and we are going to see all the 3 sections in detail along with the problems asked in GATE. So, let us start with the BJT biasing. So, let us see a few basic introduction in BJT biasing, and then we'll start with the discussion about problems dealing with those topics. First, let us see about the amplifier block diagram. So, this is a basic amplifier block diagram. So, in this, the different blocks in this are amplifier circuit, and in this there will be an input and there will be an output. So, this amplifier circuit consists of BJT or MOSFET. So, in this we will be having input. So, input is going to be a AC input. And the output is also an AC output, but we can see the magnified output. So, we can see here the amplitude of this is small, and when it comes out of the amplifier circuit, it is magnified. And for proper operation of the amplifier, we need DC supply. So, for proper operation of the complete amplifier circuit, to magnify it, we need DC supply. Actually, supplying this DC supply, we call it as biasing. So, let us see what is a biasing, what is the definition of biasing. So, this biasing refers to the application of DC voltage, and it will set up an operating point in such a way that the signal is undistorted. So, when you see here, so whatever the input we are giving, the output should be undistorted, and also the signal should be a proper reproduction. So, this is the basic condition. So, it should be undistorted and it should be magnified. Through the whole operation, through the complete operation of the amplifier, it should be undistorted. So, that is very important. And so, this we call it as a Q point, operating point or Q point. This selection of Q point should not shift. So, it should remain in that position. So, the operating point should remain in that position. So, the Q point should be fixed throughout the operation. In spite of the changes, actually there may be 3 changes that may undergo. One is IC variation, that is collector current variation, or beta variation, or temperature variation. So, these 3 changes may undergo. In spite of this, the Q point should not shift throughout the operation. So, that is the major requirement. So, by supplying DC supply, we are setting up the operating point and our Q point. So, this should not vary. So, this should remain in the same position, and that we call it as biasing. So, what is stabilization? So, actually all these definitions are interlinked. So, this stabilization, the process of making the operating point independent of temperature. So, this process of making the circuit to remain stable irrespective of the changes in temperature or transistor parameters, we call as the transistor is stabilized. So, there is a stability factor. Actually, these 3 terms, all these terms are interlinked, as I said already. So, the rate of change of collector current, with respect to the collector leakage current, ICP not, is called stability factor, which is denoted by S. So, this we call it as the stability factor. So, what we expect is the stability factor to be less. So, the lower the value of S, it is assumed that the stability is more. There are different types of biasing. So, now we have come to an idea what is biasing. So, biasing is giving a proper DC supply such that the circuit will be stable throughout the operation. So, that is the main thing in applying this biasing. So, there are different types of biasing. So there are 5 different major types. So first one is called as fixed bias or base resistor bias. Second one is emitter feedback bias. Third one is collector to base bias, or it is also called as collector feedback bias. And next one is collector to emitter feedback bias. And the last one is voltage divider bias. Let us start with fixed bias. So this is the circuit diagram of fixed bias. So already we would have studied about the fixed bias. So just we'll see what is the circuit diagram, how the structure will appear, and we'll try to solve a problem based on this circuit. So this is a common emitter configuration. By seeing the circuit, you would have been able to identify it. So this is the common emitter configuration, where you can see that emitter is grounded, and we can see here that resistance is connected to the base, that is RB. RB is connected to the base, and we see that is a collector resistance. So to take the output from here, there is a collector resistance, and there is a VCC, that is a DC supply which is given to the collector terminal, and the voltage across the collector and emitter. So the voltage across this collector and emitter, we call it as VCE. So that is collector to emitter voltage, and the voltage across base and emitter is called as VBE. So this is the structure of the fixed bias, where resistance RB is connected between the collector terminal and the base terminal. So this type of circuit we call it as a fixed bias. So let us take a problem. Let us try to solve this problem. So determine the Q point. So the main objective is to determine the Q point, the values of IC and VCE, that is for Q point. So Q point, we are going to determine the collector current and collector to emitter voltage. So we are going to determine these two parameters for the given circuit. So here we are going to assume, so the values are given for VC. Actually what we are going to determine is for Q point we are going to determine. So it is given VCE is 8 voltage, and RB is, that is the base resistance, is 360 kilo ohms, and RC is 2 kilo ohms, and beta value is 100 and VB is 0.7 volts. So these are the values given, and this is the fixed bias circuit, and let us try to find the Q point for this. So let us apply KVL to the inner loop. So here there are two loops. One is, we call it as an inner loop along this side. Along this side we call it as an inner loop, and along this side we call it as an outer loop. So along this inner loop, we are going to apply KVL across this. So when we apply KVL, this is the DC supply, that is a VCC. So VCC is equal to the drop. So this is the source voltage, and the drop is across these two elements, that is IB, RB and plus VBE. So these are the two drops. So VCC is equal to IB, RB plus VBE. So let us rearrange the equation. So it is IB, RB. We are trying to find out this IB. So since IB is not available, we are trying to find out IB. So IB is equal to VCC minus VBE divided by RB. Let us substitute the values. So the values are known. So VCC is equal to 8 minus 0.7 volts. So divided by 360 and equal to, so we will get the value as 20.28 microamps. So next, let us determine IC value. So IC is equal to beta RB. So beta IB. So let us substitute the beta value and the IB value, which was determined in the previous step. So 20.28 microamps. So let us substitute and determine the IC value. So let us apply KVL to the outer loop. So let us apply to this. So when you apply to this, it will be VCC is equal to, so when you apply to KVL to outer loop, so KVL to outer loop, VCC is the supply voltage, and the drop across is, RC is IC RC plus VCE. So it will be VCC is equal to IC RC plus VCE. So VCC is the source voltage, and the drop is IC RC plus VCE. So it will be here as VCE. So let us rearrange it to determine VCE. So VCE is equal to VCC minus IC RC. Let us substitute the values. let us substitute the values and let us determine BCE. It is 3.94 volts. So we have determined, we know the values. So we have determined IB. So from IB we have determined IC, and also we have determined by applying the KVL to the outer loop we have determined BCE. So next, so what is the main objective? The main objective is to determine the Q point. So let us determine the Q point. So here by applying the KVL to the outer loop, BCC equal to IC RC plus BCE. So we are taking this equation and rearranging. So you can see here BCE we are taking here to the left hand side, and BCC minus IC RC. So we are having this equation, and in this equation we are trying to substitute the values. Actually we are making BCE as 0, we are making the BCE as 0 and determining IC. So when you substitute BCE as 0 here, you will be getting IC is equal to BCC by RC, and substituting the values of BCC and RC, you will be getting BCE as 4 milliamps. Similarly, let us assume IC to be 0. So by substituting IC as 0, so BCE will be equal to BCC, which is equal to 8 volts. So we have determined two values. So when BCE equal to 0 volts, then IC is equal to 4 milliamps, and when IC is equal to 0, then in this case BC is equal to 8 volts. So we have determined the two extreme values. So we have 2 points. So actually we are going to draw the graph. So we are going to draw the line with BC along x-axis and IC along y-axis. So we are going to draw the line with BC along x-axis and IC along y-axis. So this voltage is along the x-axis and current along the y-axis. So here you can see that initially we have taken BC, 2 points we have got. So one is BC is 0 volts and IC is 4 milliamps. So here the first point is 0 and 4 milliamps, and the second one is current is 0 and voltage is 8 volts. So here 8 volts and 0 milliamps. So center point, so generally Q point is taken as a center point. So generally this center point will be half of this. So when you take 0 and 8, the half will be 4 volts, and when you take 4 and 0, the half of it will be 2 milliamps. So let us draw the line and let us determine the Q point. So here let us take the x and y axis. So x axis voltage and y axis is current. So first 2 points we have, 0 volts and 4. So let us determine the Q point from the graph itself. So let us mark the point. So first point is 0, 8 volts. 0, yes. So the second point is 4 milliamps. So we can join the line, and the middle point will be 4 and 2 milliamps. So this Q point will be 4 volts and 2 milliamps. So this is about determining the Q point for fixed bias circuit. Yes, sir. So we'll see the further topics in the forthcoming sessions. Thank you.